I'm Michael Hall. I'm a PhD candidate in Dr. Vichet's research group. I'm getting a PhD in material science. The purpose of our lab is to study advanced thermoelectric materials. So we have synthesis and characterization that we perform in our labs to make materials that can be used for solid state energy generation from a temperature gradient, or it can also be used as coolers for electronics, which need more and more cooling for small areas. That's the idea behind thermoelectric materials and devices. One of our main projects when I started was energy harvesting from body heat. So we had a project through the Assist Center where we were using the temperature difference between skin and surrounding air. The small temperature difference there can be used to generate most of that power. Our most successful strategy in improving the device performance for body energy harvesting was nanostructuring to reduce the thermal conductivity of the materials, because with a much lower thermal conductivity you're able to get a bigger temperature gradient across the active material. So you just get, it multiplies the power by whatever the temperature difference is. In my research, I've made lots of several materials that have never been reported, the properties have never been reported before. And so it's really, I think it's really neat to be on kind of like that edge of things that can only be made in the lab and showing what they can be used for. I chose this lab because I was interested in working with semiconductor materials. Most of the materials for thermoelectric applications are just highly doped semiconductors, compound semiconductors, mainly tellurides, but also like antimonides. They're just compounds of different elements, and we can make all of them in our lab from elements and build it for whatever stoichiometry we want. Whatever our target is, we just aim for that. And if we need to adjust something, we have enough characterization that we're able to figure out and go back and get to what we were wanting to get to. If you're interested in building things from elements to materials to devices, we have that opportunity to really go through all of those steps and kind of get a good understanding of how all of these processes work to come together to make final products.